Welcome to the Bytecode, where we normally look at smart contracts with the people who wrote them. But today we're gonna do a little bit something a little different. We're gonna look at Vulcan, which is a development framework on top of Foundry. It's written by V and the team. So V, thanks for taking the time. Shortly
Thanks
introduce
for
yourself and introduce Vulcan.
yeah, thanks for having me, and it's a pleasure to be here. Sure, yeah. So first, I guess I want to show a bit of the documentation we wrote because Vulkan is a bit different than the other projects because like it's more of a testing framework and so on. It's not really a contract that you deploy, right? So yeah, so for people that are familiar with Foundry, which is this like development framework and tooling for writing Solidity smart contracts. Um, Basically, Vulkan is something that's written on top of it that provides useful abstractions and like clean ways of writing your tests and your scripts. So one of the reasons we wanted to create Vulkan is that we felt that the tools provided by Foundry liked a few things that such as like if you're familiar with Foundry and how you use the test there, you will see that the naming is not that great. Or I mean, it's I think it comes from the original DApp tools, which is what Foundry is based on. So, for example, when you want to impersonate an address, right, you will have to use the Foundry VM prank function, right? Or for example, if you want to, change the timestamp of a block, you will have to use the warp function or the roll function to change the block number. So we wanted to create something that had like more intuitive and easier to remember names. So this is an example of how a test would look on Vulkan. You will see that first we include some utilities for just debugging, printing to the console. We use syntax or templating similar to what Rust does, right? So you basically write the string you want to print, and then you ADI encode the arguments, so you can like print many different things. You also have utilities to print numbers, and you have this modifier, for example, the decimal modifier that allows you to work with token balances and ETH amounts in an easier way. We also abstract away some of the Foundry VM functionalities, such as running external commands. So, for example, here you can see this nice way of, just calling ping or whatever you want to run on your computer, right? With the syntax, we'll go more into detail when we go into the commands module. And also, we have this kind of jest-like assertions, if you're familiar with the JavaScript world, right? In which you can do like, I expect certain thing to be false or to be true or to be equal to something else. Um, that's more or less like the justification we did all this. Like it's just basically offering a nice API to work with, and yeah, maybe we can go into specific modules. What do you think?
Yeah, it would
Do
be so this is really cool. The format numbers as decimals, that one alone I would have used like a trillion times by now.
Yeah,
So
yeah.
yeah,
I mean,
this is super nice. So definitely super interested in
nice.
how you guys implemented that.
Sure. Yeah. We can go there. First, maybe we can look a little bit into maybe just the first module to show you a bit like how we changed some of the naming for certain functions. So, for example, if we go to accounts, you will have many different modules that we've created, but you can see how easy, for example, it is to create like a pseudo random address and then work with it, right? Like here you see
Mhm.
just do accounts.create, then you do use the expect function that I showed earlier, and you can do like things like not to equal something or not to be whatever. So, and for example, when you want to impersonate an address, instead of doing like frank or calling the VM directly, you can do, let me check if here. is just impersonal, right? So you can do like you can create the account with this label, you can set the balance and impersonate all in the same line. Like it's anything is pretty readable this way instead of doing everything with this with the like directly calling the so yeah, this is just an example, but now we can go into the code of how these modules work. Um, okay, so you want to see the print line implementation. So one thing about Vulkan is that we're not really constrained about with gas costs, right? Because
Yeah.
these things are not deployed, so we can basically do pretty much anything with Solidity. So print line actually uses our format module behind the scenes. Um, we we basically so we create these hashes which we will use to compare against the templates that I show. So the template would be the thing that goes between the brackets, right, in your templates in your template string. So for example, if you want to print hello world and you want the world to be a parameter, you would do hello in between brackets you put an s or write string so that the code can actually check what type you have to decode in order to print it. But yeah, let's look at the code. It will be a bit more easier to understand. So yeah, I guess most of the logic is here. So you pass the template, which is basically a string, as I said earlier, and we want to find like the next placeholder in the string, which would be the thing that's between the brackets. So we find the first bracket, then the end of that, and then we basically check what's inside of those brackets, and that's where we compare the different hashes that we defined earlier, right? So we check if it is the UN template or an address or Boolean, whatever, and then that returns a placeholder uh, struct, which tells you, well, the start, the end, the type of the template that we're using, and if it has a modifier, right? Like as I showed you earlier, the modifier would be like, in our case, we have only implemented the one for decimals that you mentioned earlier, right? But we can eventually expand this and create other, for example, maybe we could add one for addresses that prints it in uh, checksum in a checksum way or something like that. We can expand that. Yeah, so this is the main function that you pass a string, you pass the AVI encoded arguments for that template. Uh, we will parse the template, and that will run that find placeholder function and return all the placeholders. And then we will, given those placeholders that I just mentioned and the arguments, the AVI encoded arguments, sorry, it will return all the decoded arguments. So it will return them in a way that you can easily print them. So for example, if you encoded an address, the decoded string will be a hexadecimal representation of the address, right? And then
Mm.
you call the format function to actually replace those things in the string.
I have a question, V,
Mm-hmm.
a more general question. So,
Mm-hmm.
one episode we had a Foundry plugin, and most of the logic was like calling into Bash scripts. So my
Oh,
question
okay.
here, wouldn't it be easier so basically you wrote your own templating and parsing logic in
Mm-hmm.
Solidity. Wouldn't it have
Yeah.
been easier to like write it in a bash script or something else, do your calculation there, and then jump back into to Solidity and just pass in the answer? If you understand what I'm trying to
Mm-hmm.
say?
Yeah. Yeah. No. Yeah. That makes sense. So I guess I mean that's a possibility for sure. The thing is that it would probably be a little bit slower to do it that way because you have all the overhead of calling the external bash script. But also, if you want to call external commands, you need to enable FFI, the foreign I don't remember the abbreviation, but
Yeah,
you need
and
to
I can never
allow.
remember that too. Yeah, I think it's
Yeah,
foreign function interface or something like
yeah,
that.
exactly, exactly. Yeah, that's the one. But yeah, you would have to enable that as well. So if you're using just print line or formatting stuff, you don't need to do that really. So I guess that was, and also because it's fun to just push Solidity to its limit. Yeah.
Okay, I think that's the main reason, dude. Because even from a development time standpoint, I think writing this in something like Python would be like 10x faster, probably.
Yeah, yeah, I guess so. Initially, when we started writing Vulcan, it was really just a fun project, and just we wanted to, break conventions and do whatever inside Solidity. Because I mean, even though it's limited, it's quite capable if you're not constrained by gas, right? So yeah, I guess is the way we did it. But yeah, for sure, that's also another option to
Okay,
just running an external script.
okay, okay. No, makes sense, makes sense.
Yeah. Do you have any questions about this part of the code? It's pretty simple, really. It's just as I said, that I guess the hardest part was to decode the different arguments. But once you have those placeholders, you can just call to string and you turn them into whatever you want to print. Oh,
Hmm.
well, I can show you because this is the format module, and it provides you with the format function that I showed. But then we should have it around here. Let me check. Oh, we have the utils module where we actually provide like file level functions, and here you should be able to find the print line, right? So basically, the print line that directly logs into console instead of having to first format the string and then pass it to console log. We pass the template, we pass the args, and as you can see here, we do format that returns a string, and we call raw console log, which calls the kind of console address in the Foundry VM that actually prints stuff to the console. So yeah, and these utilities, well, this comes from Forge SD, but we have a few here. And this, you can just import directly into your code. You don't have to import like a specific module. Just import the function and use it. So like if you don't want to use the whole Vulkan modules, you could just do like import print line and just go with that.
Okay, so I can also
Um,
import what I need as a library
yeah,
into my
yeah, yeah.
existing
So
project.
yeah, we have different ways of importing things. So the original way was to just import test.sol, and that kind of imports everything, right? So you could do, um, import whatever, like a huge list of things from test.sol, from Vulkan dash test. But now we're kind of figuring out if we should move to maybe importing directly from each module, because that could shorten the compilation time if you're not importing all of the modules, right? So yeah, I guess actually this is a good second thing to look at. This is like the base test um, contract that your test contract has to inherit from, right? So well, this actually is pretty similar to Forge SD test in that it defines a few different utilities, but your contract has to inherit from. Um, and then actually, let me show you a example test that we have here. So here you can see, well, we missed the license, but you do example test is test here. As you can see that this is the original way of importing things that we were mentioning before. So you import all the things you need from test.sol, and then you just inherit from test, and then you can start using the stuff. So for example, some of the modules are, well, all of the modules are libraries, but some of them have this functionality that you have to do like using accounts for X. So for example, if accounts defines a bunch of methods for addresses, right? So once you do using accounts for everything basically. You could also do it just for accounts, but then you could do things like once you once you do accounts.create, this will return an address. And as we did the using accounts for addresses, then you have this different functions defined for it. So you can do everything in a builder kind of pattern, I guess. So you could set the balance, set the nonce, or do different things like impersonate, calling that directly on the address. So yeah, this is just more examples of how to use Vulcan, I guess. Oh, well, we can go to accounts module because there we can see how we kind of wrap the Foundry VM. Sorry if I'm a bit all over the place, but we have many different modules and it's kind of yeah. So okay, um well, here you can actually see exactly what I was referring to, in which we defined the HEVM. It's just the address, right, that has the Foundry VM interface. We get the Foundry VM interface directly from Forge SDE because they keep it updated. So as you can see here, some of the functions are exactly the same, like sign, just call the sign function the HEVM. But for example, for impersonate, here's where we start doing some more stuff. Well, apart from actually changing the naming, instead of just calling prunk and doing impersonate, sorry, we rename it to impersonate, right? We also do a few things that the prunk function doesn't do by itself, which is when you're impersonating an account and you want to impersonate another one, you have to stop impersonating the original one. This might actually have changed in recent versions, but yeah. So, but this basically does that. We have some functions to like apart from only wrapping the VM functionality, we'll also do a few things internally that are useful as well. So yeah, the accounts module is basically a wrapper around the VM, but with better name, in our opinion. So for example, the deal function, which was to set the ETH balance, right? We just rename it to set balance. I think it's just easier to remember that way. But we also have some additional functions like minting ERC20 tokens. This is quite similar to some of the functions that Forge STD has. We love Forge STD and base a lot of stuff around how they do things. So yeah, I don't know if we should continue going through this or maybe go into more of the obscure internal details of the different modules.
Definitely. But first, I have another general question. Maybe you know the answer
Yeah.
of that. Is there a
Mhm.
movement inside Foundry to actually rename these? As you said, out of history, I didn't even know that. Like the
Mm.
history is this naming was taken from dApp tools.
Yeah.
But it's really weird naming, right? I totally agree. Is
Yeah,
there
I
like a
mean,
PR or an issue or something on GitHub where someone wants to rename all of
I
them?
I don't think so because I mean it would break everything, right? Like all the projects. I guess
Yes.
one option could be to define like a new VM address, like an alternative one that where you could define these things. But I don't like it is possible to write things on top of it, right? So for example, Forge SDD could eventually just rename the things and abstract away the VM. So
Mm,
I think it would be too problematic to do it at the Foundry VM level right now. But I don't know. I mean, I'm not sure of the plans that the Foundry team has. But
okay.
yeah,
Feels like we're
yeah,
gonna be just stuck with it forever. So it is what it is.
maybe. Well, you have Vulcan, so you can
True,
you can use
true, true, true.
that. Yeah. So well, maybe we can go into how results work because that's like a thing that we implemented recently, which is kind of different to how you use Solidity most of the time.
Mm,
A good example of that is the commands module. Well, the commands module is also a wrapper around the FFI function. Just provides like a simpler interface to working with it. So yeah, so a command is just an array of strings. which will be like different things that you want to run with the FFI. But we just provide an easier way to work with it, right? Because as FFI receives a dynamic array of strings, you know how in Solidity you have to do like string array, memory, blah, inputs or whatever equals to a new array, right? And then you have to line by line pass all the different inputs that you want to use. Here we use also like a builder pattern. Like you could do uh, create the command, do arg something, dot arg something else, blah, blah, and you have like a builder pattern, so that's easier to use. But also, we went ahead and defined a bunch of different functions for the different, the different lengths of strings. So yeah, that was painful, but basically now you can do things like, let me show you maybe in the, so basically, you could do something like, commands dot oops, dot create, whoops, and you can do like, you know, pain and start adding stuff like that,
Hmm.
So that's also a bit easier to work with, right? So yeah, so oh, and what I wanted to show you about this is that when you run a command, there's this run function around here. Yeah, that you run the different inputs, and it will return a command result. It will not return like the output directly, right?
Hmm.
And why we do this? Because the try FFI function can actually return an error,
Hmm.
right? And so I don't know if you're familiar with Rust, but they have the
Yeah.
result kind of data type, right? In which it can be an actual value or it can be an error. So we try to mimic that internally.
Hmm.
So, for example, if everything went well with the FFI, then we just wrap the output in an OK, which is a command result. Well, I will show you later how the OK maps to the command result. But if it is an error, we use what we call error functions. Okay, so basically, not executed is an error function that then we turn into a command result. And then when you in your code, like in your test or in your script, when you're using this, you call run, and then you do the same thing as you do in Rust, right? You do dot expect and pass an error string. So if it was an error, the expect function will actually make the thing revert, or you can just do an unwrap, same as with Rust, in which it will also revert and provide like the default error message. And if it wasn't an error, then it will just return the output. Maybe I can show you an example of that as well. I'm not sure the example test. Oh well, we have tests for the command module, so I can show you. Yeah. Okay, so well, um, so as I was saying earlier, we can do run, we pass echo, and then hello world, right? And then this will return a command result. And then but this is not the actual output. To get the output, you have to do the unwrap, and that will contain the std out and all that stuff. So if this was an error, if for some reason the echo function, the echo script failed, then this would make the test revert. If not, it is just the actual output, and you can use it as usual. Does that make sense? Is it clear to understand? So,
Yeah,
so
I
the
really like
Mhm.
this. I really like this V. This is yeah, it's always super annoying to work with FFI stuff in general, and this makes it a lot easier to debug stuff and deal with errors.
Yeah,
This is nice.
yeah, actually, I will show you our request module, which uses commands behind the scenes to, it's just a wrapper around curl.
Hmm.
And I will also show you how you can create, for example, like a Discord client in just like 3 lines of code. It's pretty cool to use. But
Nice,
the reason we
nice.
went with this more complex approach to dealing with errors and stuff is because, again, this is not something you deploy, right? This is something you're using in your scripts, and your scripts will have more logic that can go wrong, right? Like you might be interacting with a website or whatever, so or with an API. So we wanted to have like a more robust error handling in case you're actually writing like a complex script or something.
Hmm.
So yeah, so well, this is the commands, and maybe we can go to requests. That will this there's a lot of information here, but this is how you use it. This is a test for how to use the request module. As I said, it's just a wrapper around curl, but provides like a nice API to work with. So yeah, just create a request client. You can do like a get, pass the URL. You also have like authentication or the usual helper functions. Then do send, and the send will return a response result. So you have to do the unwrap, or you could do expect, pass the error message that you want. And the result, as we have already unwrapped it, it will contain the status, and you can actually turn that result into JSON that will try to parse the body into a JSON object.
Okay.
But that can also fail, right? Maybe the body is not
Hmm.
JSON, so that's also a result that you unwrap or pass an error string,
Hmm.
right? So yeah, so it's all like it kind of makes it a bit more complex, but I think if you're really writing something that it's more complex, that it will have its benefits to be able to handle errors in an easier way. Um, yeah, and so yeah, you can do posts, and you can also pass a JSON body by just doing JSON, or you can pass a JSON object that is also one of our modules that wraps the VM functions for JSON object.
Hmm.
Um, and actually, I have an example of how to write a Discord client. Like if you want to send a notification to a Discord channel, right? You just do uh, well, we define this Discord client struct that will have a JSON object that comes from our JSON module, and um, and the request builder, which comes from the request module. So
Hmm.
it is really simple, right? So you see, content sets the content for the message, and basically here we just set the content field of the JSON object to the content that you're passing. You can also set username, avatar URL, etc. And when you're creating the Discord client, you just pass the webhook URL. So then it looks like this: client discord.create, pass the webhook. I don't remember if this is like the actual URL you would use, but in your Discord channel you can create like this webhook URL. You pass that, and then you just do this, and yeah,
Hmm.
you get a notification. So it's kind of these different building blocks that you can use to build more high level stuff.
Yeah, you could put that into your CI/CD and stuff. If your Foundry
Yeah,
tests fail, you ping the Discord. That's
exactly.
yeah,
Yeah.
yeah. That's cool.
Yeah. Okay, so maybe next we can go to, well, maybe we can continue with how results work. It is a bit more involved than just like the unwrap and expect. Well, we have all this concept of error functions, which is kind of difficult to understand, but like if you're using it, you don't really need to understand everything of how it works. You just use the thing. But
Actually, V,
well,
I would love to take a look
mhm.
at the client implementation, how you wrap the curl.
Oh, okay, sure. Well, let me check. Uh, okay, so here we go. There's a lot of stuff here, but basically, yeah, so the different results, right? When you unwrap them, you want to receive a specific type, right? So, for example, if it is a string result, you will receive a string. If it is a JSON result, you will receive a JSON object when you unwrap. So basically, for all of these types that could be wrapped in a result, you have to define a new result type. And that's because, Solidity doesn't support generics. So basically, we have to define these things for every different type that we want to support results for. So the request result, as you can see, is just a byte 32, which is just like a memory pointer, right? So we will encode in memory the actual result, like the value, or the error, if it is an error. Okay, so then when you're unwrapping it, it will determine, okay, it was an error or it was an actual value that we have to return. So the the request struct just defines what you're doing, like a post, a get, or whatever. The URL, the headers, and the body. The response is pretty much almost the same thing, but has a status and doesn't have a method, obviously. So the when the request module, this is like the entry point, right? You do request.create, and that creates a request client. Initially, we do actually we run this curl dash dash version to see if you have what we need to use our request module, because there are some things that are not present in all versions. I believe it was some stuff about headers that we needed to parse. But yeah, so when you create it, we'll check the version, and we also have a semantic versioning module that will be able to parse the function. That we just built it for parsing the curl version, but you can use it for your own stuff as well. So yeah, we create the headers there, and then this returns the request client, and the request client has all these functions defined, right? So you have the get function, del function, patch, post, and the usual stuff. It's inspired in request from Rust, this REQWEST. This module from this is it's a crate from Rust, and we try to follow the same API. So yeah, so when let's say you want to do get, as I showed, you do like request dot create dot, and then you have the client, then you do client dot get, pass the URL, and that will return a request builder. And the request builder, let me check. Whoops, it should be lead request builder. So the request builder has the different functions that you would use to build your request, right? So you can pass a body, which could be just a string, but it could also be, as we can see here, let me check. Or you can actually do JSON and pass a JSON object, or pass a JSON object, but like the string of the JSON instead of using our own abstraction, right? And that would also set the header type. So, to signal that the content of the request is JSON. Yeah, and once you have built the whole thing, for example, you have the basic auth, which just uses the header function to set the authorization header. You also have like the better auth, and like you pass the token, simple stuff, but it's pretty useful instead of having to do the base 64 encoding on your own. Like you can just use this and it will work. Yeah, and once you have your request ready, you call send, and that will build. If I'm not mistaken, this will create the actual script in the bash. Sorry, the bash script that will run, and I'll show you in a bit. And this will return a response result. That's the thing that you have to unwrap or do the dot expect to get the actual value. And so let's go to build. Oh wait, I think it doesn't. Oh, for some reason. Oh no! Oh, sorry. Oh, it's executed. We built this a while ago. So okay, so um, let me check where was the curl code. Okay, so here's the code. Okay, so when you call execute, uh, we will turn the actual request into the command, which is this function here. And that will actually write the whole curl stuff. So this is the thing that we're doing. Um, it is not, I guess, easy to understand, and we could probably simplify this stuff, but it worked, and we didn't want to change it that much after that. But it's probably possible to simplify it a bit. But basically, we tell curl that we want a few different things, such as, the we want them to output the headers in a JSON object, and we want also to get the HTTP code result. This is telling the curl to do that. And then once we get the response, right here, we do a bunch of manipulations on it. We get the headers invalid, we get the status code, and we get the body of the response. And then we call cast API encode. This also comes when you install Foundry, right? Because it allows you to interact with a node, but also has some cool utilities to API encode stuff. And we actually shout out to Searl, which is also a library that does wrap curl to use in Foundry. We just added a lot more features, like being able to set the headers in an easy way and stuff. But yeah, so basically what we do is once we get all the stuff back from the request, we API encode in this way. We say we get the status code, the body, and the headers all in a string. Sorry, the headers in a string, the body in a string, and the status code as event. And then we use the commands module to create the script. So here we go back to where we were building it. So we turn it into a command. We call run. This will return a command result that we saw earlier. We'll check if it is an error. If it was an error, we just turn it into a response result error. So basically, if it was an error and you do the unwrap here, it will revert. But if it was okay and it returned an actual response, then we get the command output and we parse. As we had API encoded it with cast, we now decode it here in Solidity, and we get the status, body, and headers. Does that make sense so far? But yeah, basically all that is just to parse the response, the status code, and the headers. And then we return a response. That's also wrapped in a response result. Because yeah, we return a response result.
Okay, I'm very glad we looked at this because this shows how much heavy lifting you guys had to do to, provide this nice API in the end.
Yeah, I mean, yeah, it's always trade-offs, right? I mean, I use for complexity, but I think it really pays off when you're writing more high-level stuff. As I showed, like the Discord client, it was really, really easy to use. Like,
Yeah,
we were surprised on how easy it was to build and to debug and stuff because you already had all this. But
nice.
yeah, and yeah, maybe we can go to some more obscure modules that we're actually thinking of maybe removing from Vulkan right now because we actually haven't even documented them, but they're pretty fun. Or do you have any specific questions about results or errors?
Well, let's do that for sure. But one thing I'm
Mhm.
also interested in is the JavaScript testing style, like how you guys
Oh, the expect
implemented that.
function. Okay. Yeah,
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 yeah, yeah.
makes sense. Okay. Let me check. It should be the expect module. What is it? Oh, this one. Yeah. So yeah, as you were mentioning, we have this kind of jest style expectations in which you do expect, pass whatever, like the results you got from something, and then do dot to be or to equal something or to have or to contain something, etc. So that's and to do that, we wanted to make it type safe because originally we actually were looking into just making a generic return from the expect function that would have allowed us to shrink the code quite a bit because you would basically have a few matchers that would use the same kind of structure to work on. But we ended up going for a more verbose, but basically type safe implementation, in which you have like for each native type, you have an expectation struct, and you also have like the inverse or like the negative expectation struct. So for booleans, it will contain the value, but also you have to define like the negative, like the bool expectation not. Um, and this is so that you can do like expect something dot not to equal something else. So instead of, you know, it's like the same as yes. So yeah, we have all these different expectations again for unts, bools, bytes, you name it. So we have all this, and the the expect function, which is I guess the main entry point to all of this is, sorry, it should be here. Right. So for each native type, we create an expect function, and it will return the the expectation struct that I showed earlier. So for bools, we return a bool expectation, and so on. And then we have this library that defines the different matchers for each of these structures, right? So for example, let's see, to equal, right? This is a simple one. To equal receives a bool expectation and the expected value. This will call um, the other to equal that also receives a message string, and it will just print like the message that the user passed or an empty message if we're using like the default message, and show a bit about the information of why it failed if the actual value that you received is different from the expected one. And we do that for all the different types. So yeah, that's pretty much it. It's pretty simple. It's just a lot of repetition here because we have to do it for each different type. But well, we have some like more high level ones. Like for example, for string expectations, we have the to contain matcher. So you could pass like a substring, and it will check if the substring is contained in the string, and so on. We're also planning to extend this for arrays. So you could have like expect an address array to contain a specific address or something like that, instead of you having to loop through the address and check if the address is there. But again, that's a lot of a lot of repetition. We would have to do it for all different types of array and so on. So yeah. Um, yeah. Also, I guess like we could also maybe eventually use some kind of templating engine to kind of define, like automatically generate all the different matchers for the different.
Hmm.
But yeah, we haven't gotten to that point yet. But yeah, this pretty much has everything you need. And if anyone watching finds that there's maybe a matcher missing or something, just send a PR or an issue, and we'll add it. So yeah, that's pretty much it. It's pretty simple, really. Uh, um,
Nice.
well, we have a one that I think we're not that happy with how it turned out, so we don't have much documentation in it. But basically, we have this special kind of expectation called call expectation, okay, which it has a call, which let me check where it is. Maybe it's in should be in watchers, I think. One sec. Uh, yeah, so the language server is not not great, but yeah, where it is, I think it should be in watchers. Yeah, this is like one of the modules that is a controversial one because we're not sure if we want to keep it yet. But yeah, calls. Yeah, so calls are basically call data, uh, about if it was successful or not, and the return data and the logs that the call emitted or that were emitted in the execution of that call. We had defined this module which basically allows you to watch an address. Okay, so you do you pass the address that you want to watch, and behind the scenes we will replace the code of your address. Okay, or even if it is an external account, we will just put some code in there. And what it will do is that anytime that address is called, we will record all of these calls. So then with the expectation module, you can do expect this address's last call to have failed, for example, or to have reverted, which is a bit different from the usual assertions that you do in Foundry for failed calls, right? Because you have to do like vm dot expect revert and then call the function, which always felt a bit kind of unintuitive to me because you had to. And in this case, you would just call it and then do like expect the previous call to have reverted, if that makes sense. But I think it's a bit too complicated for the actual benefits. So that's what we are figuring out if we want to keep it or not. But
Hmm.
yeah.
Okay, so what you could also do is like in this test I called into this address like 6 times, right? This is something I could do.
Yep. And you can
Okay.
get all the calls and check, for example, if they were successful or if they emitted some log or the return data was something. Yeah.
Hmm. That's interesting. Because you're right, the expect revert always felt weird. Like even if you
Yeah.
do, even if you do a function call inside a function call, like on one line, and
Mhm.
oh, this always happens to me. And the expect revert, it's only on one thing, not the other.
Mhm.
Um, hmm. Okay.
And
Yeah,
and
I think you can build something really interesting out of this.
yeah, so this kind of is the base of what we want to do when we implement like a mocking framework. Because for mocking, um, you want to also kind of be able to register calls. Sorry, is it too noisy? There's some noise outside. But
No, it's all right. It's all right. I didn't hear that at
okay,
all.
cool, cool. But yeah, and the cool thing about the watchers, I guess, is that even though you replace the code when and you record the calls, but the actual functionality is still run. You're actually executing the logic because when we replace the code, we we turn the address that you pass into a proxy. Okay, so you have your contract that you're watching. We replace that with the proxy logic that will record the calls, and that proxy will actually delegate to the actual implementation, the original implementation. So
Hmm.
it's not like you're just replacing everything and just recording calls. Like you are actually running the exact same implementation, so you can check if the call failed to the implementation. It's not just just replacing it with dummy logic. You're actually running the implementation behind the scenes. It's kind of a weird model, but it's the only
Hmm.
way we found to do it. Yeah.
Okay, but doesn't that have a lot of side effects? Like
In
if
which
you re
sense?
like if you replace just okay, instead of calling directly into my contract, I call into a proxy that delegates into my contract. That's
Yeah.
how I understand it.
Yeah, but you're
Uh,
calling the original address of your contract because we just put the proxy code in there.
oh, I see. I see.
Mhm.
Okay. Oh, okay. Yeah, I can see now where the complexity comes from. Okay.
Mhm. Yeah, and you did, and it does a delegate call really. So
Yeah.
basically everything is still done in the context of the address or the account that you originally uh, passed. So
Hmm.
let me check if it's around here, but let me check. Oh, here it is. So the watcher proxy is the one that we put into into your contract, right? So we pause the gas metering only for the recording stuff. Then we enable it again when we're actually doing the delegate call. Okay, so you in theory still get like a good gas measurement. Um, so uh, yeah, when you call your now proxy, um, basically we will begin recording logs if it is not a static call. The static call is also a fun one when I can show you later, but it basically checks if you're within a static call, right? So
Hmm.
if it is not a static call, you start recording logs. we do the delegate call and we get the return data. The to-do ugly, try to clean up. But
Yeah, the
yeah,
classic to
well, we
do.
don't have to really deploy anything, so we can do things like this, and it's okay. Uh, but yeah, so uh, if it is not a static call, then we get the recorded logs as we started recording earlier. And basically, here, let me remember what we were doing. Address. Right. So we start uh, filling up the different logs in the structure of the call that I mentioned earlier. So where's the storing the call? Let me check. So okay, so yeah, once we get the logs, we filtered logs, we get the watcher address where the actual data is stored because sorry, this gets more complex by the minute. But the thing is that as we're doing a delegate call from the proxy into your implementation, that means that the storage layout of the proxy, we don't want to mess with that, right? Because it could mess
Mm,
with your contract stuff. So we actually store it in a watcher contract and we store the call there. And so then when you ask the account, give me your calls, we're actually getting the calls from the watcher. And yeah, basically, that's the main. This is the main function. This is the proxy that we actually inject into your code, and then it should be here. So then, if you were watching an address, you can do address dot last call, and it will return the last call that we recorded. So yeah, that's like the main gist of it. But
okay.
yeah.
And
Oh, you can also sorry.
you're thinking about removing this from Vulkan?
So maybe simplifying it a bit, or
Hmm.
making it easier to understand and to really figure out all the benefits versus the complexity. Because I mean, obviously, there could be some additional things that we're not considering, such as maybe it does still um, like increases a bit the gas cost because you are still calling the VM functions behind the scenes. So maybe this could mess up. I mean, it does mess up a little bit your gas calculations. So we would need a way to integrate it into our gas reporting in order to,
Hmm.
to correct it, or just be really specific in how it messes with your calculations so that, you don't get any surprises later on. So yeah, we just need to think a lot more about it because this was actually one of the first modules that we built, and yeah, we haven't really updated it much because it's not really something that most people need, or it doesn't provide that many benefits over just doing the expect revert.
Hmm.
But it's an interesting pattern for sure, and it was fun to build again. So we just went for it. Yeah.
Nice,
Um.
nice.
Yeah. That's the watcher. Um. Oh, one thing that we haven't really looked into. So this is this one the half um we have some modules to work with other languages. So half is this middle language. Also, we have for Fay. Basically, these are wrappers of the FFI again, or well, they are wrappers of our commands module, and they use our commands module to run the compilers for these languages. This one, the half module, was implemented by J.T. Riley. Yeah,
Hmm.
he helped us, and he built this like in like 30 seconds, and yeah, it basically just uses the commands module behind the scenes to run the compiler for these contracts. Um, so yeah, you can see here how you're building the command, right? You pass like different options to this half C structure, and it will transform that into a command that we can then run and compile the code. And yeah, the code is pretty straightforward, but the way you use it then is let me show you the test. Is the huge this one. So Yeah, so this is the way you could use it. Basically, do half module dot create, set the file of your half code, and then do compile, and that will return an init code but wrapped in a result. So you do init code dot wrap, and then you can actually deploy that bytecode if you want. So yeah, and the FA module is pretty much the same thing. It's just like a wrapper on top of the compiler of these different things. So it's pretty easy to build this module. So like there's some other uh, compiler we could also wrap it and provide you the init code so that you can deploy it from within a Foundry script or a Foundry test. Um, yeah, those. I guess we've covered most of the main stuff. Because like the other stuff is again pretty straightforward, just wrapping the VM functionality. Um, yeah. Do you have anything specific that you might want to check out?
No, that's a great timing, V, actually. We're at 56 minutes.
Awesome.
This was super interesting, dude. So I actually, you guys would have saved me a lot of time if I knew of Vulcan beforehand, but I only knew of Vulcan when we interacted on Twitter.
Right.
So yeah, super. This is like a productivity hack for anyone who uses Foundry. So yeah, thank you guys for writing this.
No, thank you for your time. Like we're always looking for feedback. We have a few users, but we're still trying to, get really a lot of feedback, and so we can, just focus on whatever people need. We at Namoi, which is our company, basically we just do audits that gives us the possibility to actually work on this
Hmm.
cool open source project. So yeah, most of our free time we just work on stuff like this. So yeah, we will continue to upgrade this and add more modules and create more fun stuff. So yeah, if anyone watching has questions or ideas for features or improvements, just send us an issue or join the Telegram or yeah, we're happy to. We're pretty fast to respond and to implement stuff. So just just let us know. And yeah,
Nice.
thank you
Is
for
there?
having me again. It was
Yeah, of
fun.
course. Is there like a is there like a module that one could build as a first PR or something like for someone who wants to
That's
contribute?
interesting question.
Something not
I
too
think well,
hard but still useful.
Um, it would be interesting to start looking into the mocking framework. I know that I think DeFi Wonderland launched a mocking framework for Foundry just a few weeks ago. So it would be interesting to see like if maybe we want to integrate with that or if we want to build our own thing. So just maybe start to roll different ideas and collaborate on that. We've had people, for example, adding the expectations that we had didn't have like you weren't able to provide like a default message, so someone went ahead and just proposed that, and like the same day or the next one they had already created the PR, and it was done. So again, we have a lot of flexibility because these are not things that you want to deploy. We can just change stuff around, and it's fine. So it's a pretty nice code base to, I guess, look into what Solidity is capable of without without dangers, right? So yeah, it's a
Yeah,
fun
yeah.
project.
Okay, okay.
Cool.
Okay, one last thing is okay, you
Hmm.
obviously there is this movement in the EVM world of okay, let's rewrite everything in Solidity, right? And I think the Foundry
Mm.
guys started that. And you obviously are also part of that.
Mm.
Um, on the other
Well,
hand, obviously Solidity wasn't built for stuff like this. I think it's
yeah,
something fair
yeah,
to say.
yeah, for
Uh,
sure.
yeah, what do you think about this? About okay, let's
Hmm.
rewrite everything. Let's build a Discord bot in Solidity and see what happens.
Hmm. Yeah, so I think not having to change context between the different languages that you're using, right? So, for example, the productivity boost that you gain when you start writing your tests or scripts in Solidity versus having to go to JavaScript and use a library that maybe the big numbers don't work well or whatever. Like you start getting into all these things instead of just, you know, getting into the flow and coding everything right away. So I think there's value on being able to write more complex things. That's on the like actual benefits of doing this. I think it's pretty nice to not have to switch contexts. On the side of if you're building stuff like this, I think it's really fun, and that's I think at least for me is really important because you know just fighting with the limitations of something makes you or forces you to be much more creative in how you do things. So I
Mm,
think that's also a nice you know thing like you're still exercising your brain and having to come up with shortcuts and maybe doing this you can find ideas to then apply to your actual contracts or whatever um, and yeah and I think the domain specific languages for smart contracts will always be well I don't want to say always but will probably be the best way to interact with contracts for the time being, like in the short and medium term. I think it's just too easy, right? It's much simpler. For example, I've been looking into writing Rust contracts or other stuff, but they are just a lot of additional complexity. While here you can just do things in a
mm,
really a simple way. So yeah,
that's true. That's true.
it's just trade-offs, but I hope that that made sense.
No, definitely. V, thanks again for taking the time. If you, I think the best way to reach out to you guys is the GitHub repo or on Twitter,
Yeah.
right?
Yeah,
I'm
Twitter and
gonna,
we have also a Telegram for Vulcan that you can find in the repo. So yeah, and
okay.
thanks for having me again. It was really fun.
Yeah, of course, of course, of course. Likewise. Yeah, I'm gonna put every link in the description down below as always. V, thanks for taking the time, and guys, see you in the next one. Bye bye.
Thank you. Bye everyone.